This video will be about Section 1-2 in college algebra in context. We will discuss graphing equations using the point plotting method, graphing equations using graphing calculators, aligning input and scale outputs to model data, and graphing data points. First, we're going to graph the equation y equals 2x squared by drawing a smooth curve through points determined by integer values of x between 0 and 3. Then we're going to graph that same equation by drawing a smooth curve through points determined by integer values from -3 to 3. First, we're going to graph the equation y equals 2x squared by drawing a smooth curve through points determined by integer values of x between 0 and 3. Then we're going to graph that same equation by drawing a smooth curve through points determined by integer values from -3 to 3. First, determining the points for A. If x equals 0, 0 squared is 0 times 2 would be 0, so the point would be 0, 0. If x is 1, 1 squared is 1 times 2 is 2, so the point would be 1, 2. If x is 2, 2 squared is 4 times 2 is 8, so the point would be 2, 8. And if x is 3, 3 squared is 9 times 2 is 18, so the point would be 3, 18. So now we have the points for the first graph. And now let's determine the points for the second graph. If x is -3, -3 squared is 9 times 2 is 18. So we'll have the point -3, 18. -2 squared is 4 times 2 is 8. So we'll have the point -2, 8. -1 squared is 1 times 2 is 2, so we'll have the point -1, 2. 0 squared is 0 times 2 is 0, so we'll have the point 0, 0. 1 squared is 1 times 2 is 2, so we'll have the point 1, 2. 2 squared is 4 times 2 is 8, so we'll have the point 2, 8. And 3 squared is 9 times 2 is 18, so we'll have the point 3, 18. Now we're going to go ahead and graph both of these sets of data. Now we're going to go ahead and plot these points. We need to number the axis. The x-axis we can number 1, 2, 3, 4. The y-axis, we don't have quite enough room, so I'm going to number by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we have the point 0, 0, the point 1, 2, the point 2, 8, and the point 3, 18 we had, and we want to draw smooth curves through those points. So hopefully I can get fairly smooth here. So the graph would look like that with values between 0 and 3. Now we're going to draw the points here, and we'll number the graph the same. So we will have -3, 18, -2, 8, -1, 2, 0, 0, 1, 2, 2, 8, and 3, 18. and drawing our smooth curve. I'm not always the best about drawing the smooth curve on this pad. So you can see what shape we generally have there. Okay. Now, a complete graph, as we'll look at on the next slide, has to have the places where we go through the shows important points where it crosses the x-axis, and this one just touches the x-axis, where it crosses the y-axis, and any turning points. So this one has a turning point. This one we cannot see a turning point, so it's not the best graph. So as I said, a complete graph shows the basic shape of the graph and important points, including the points where it crosses both the x and y axis and where it turns, and suggests what the unseen portions of the graph would be like. So here we want to sketch the complete graph of the equation f of x equals x cubed minus 5x, using the fact that the graph has at most 2 turning points. So we'll make a table to determine some points. Now, negative 2 cubed is negative 8 minus 5 times negative 2. So it'll be negative 8 plus 10, or 2, and our point will be negative 2, 2. Negative 1 cubed is negative 1 minus 5 times negative 1. So negative 1 plus 5 will be 4, and we'll have the point negative 1, 4. 0. 0 cubed will be 0, minus 5 times 0, we'll get a 0 again, so we'll have the point 0, 0. 1 cubed is 1 minus 5 times 1, so 1 minus 5 will be negative 4, and we'll have the point 1, negative 4. And 2 squared, or 2 cubed will be 8 minus 5 times 2, so 8 minus 10 will be negative 2, and we'll have the point 2, negative 2 to graph. Go ahead and graph. So we had the point, oops, I believe we can number this graph by ones both ways. So we have the point negative 2, 2, the point negative 1, 4, the point 0, 0, the point 1, negative 4, and the point 2, negative 2. So drawing a smooth curve through that, it looks like we go up here, turn, come down, and turn again. And I'm going to extend this, and I try to extend across the graph whenever I can. It has at the most 2 turning points. So here are my 2 turning points, and I believe I have a complete graph here. So it does have 2 turning points. It is a complete graph.